All right, let's get right into it. We're going to talk about a really clever new technique that managed to find some critical, super hidden bugs in PHP. And PHP, well, it's the language that secretly powers a massive chunk of the internet you and I use every single day.
And when I say massive, I'm not kidding. Over 70% of all websites in the world run on PHP. Just let that number sink in for a second.
You can think of it as the internet's invisible engine. It's the foundational code behind everything from your favorite blog to huge platforms like Facebook and Wikipedia. It's just humming along, silently, in the background.
But that begs a pretty scary question, right? If the engine that runs so much of the web has a problem, what does that mean for the rest of us?
And that question brings us to a specific kind of flaw, one that poses a serious hidden danger to the web's stability and, more importantly, its security. We're talking about something called memory errors. The best way to think about it is like this. Imagine your computer gets confused about where it put its keys. It might just give up and crash. Or, even worse, it might accidentally leave a door unlocked, giving an attacker a wide-open invitation to walk right in.
And this isn't some rare, once-in-a-blue-moon problem. A deep dive into PHP's own bug reports showed that more than a third, over 33%, of all their verified bugs were memory errors. It is a huge, persistent issue.
And we're not talking about minor glitches here. These are some of the most serious and exploitable types of software vulnerabilities out there. Things like buffer overflows, where attackers can literally inject their own malicious code, or use after-free bugs, where they can trick the program into using memory it shouldn't be touching. This is the serious stuff.
So the million-dollar question is, how in the world do you find these super elusive bugs, especially when they're hiding somewhere inside PHP's massive codebase, which is over 1 million lines of C code?
Well, the first line of defense for the PHP developers is their official test suite. It's the main tool they use to try and catch bugs before they cause any trouble. And this thing is huge. It's got over 19,000 individual test cases. It's so comprehensive that researchers started calling it the golden testbed for hunting down bugs. But there's a catch, a big one. Even though there are thousands of tests, each one is actually really simple. They're basically designed to check one tiny little function at a time. They just aren't built to find those complex bugs that only show up when different parts of the system start interacting in weird, unexpected ways. And that very limitation, well, that's what led to the big breakthrough. The key insight was, what if these simple tests aren't the end of the story, but actually just the beginning? Okay, so take a look at these two totally separate, totally harmless tests from that official suite. Test A on the left is just checking how PHP handles some web data. And Test B on the right, it's just testing a simple data encoding function. By themselves, they run perfectly. They find 0 bugs. Absolutely nothing. And this is where the genius idea behind a new technique called FlowFusion comes in. What if you could take these simple, unrelated tests and cleverly merge them together to create brand new, complex scenarios that no developer had ever even imagined testing? And here's what happens when you do that. By fusing those two simple tests, the system created a new program that tries to do something really weird. It tries to base64 encode a piece of an XML document. No one would ever write code to do that on purpose. And that totally unexpected combo, it immediately triggered a severe bug. A bug that had been hiding undiscovered in PHP's code for over 20 years. So how does this magic actually work? Let's take a quick look at the automated process that makes this whole thing possible. The whole process is really methodical. It starts by grabbing 2 tests from that giant library. Then it analyzes how data flows through each one. But the really clever part is in the middle. It merges the execution environments of the 2 tests, and then it intelligently fuses their data paths together. That's the step that creates a brand new, more complicated test. And finally, it runs this new hybrid program and just watches. It waits for a crash that signals a hidden.
So the big question is, did it actually work? Well, the results are in, and they show this isn't just a neat idea. It's an absolute powerhouse when it comes to finding bugs.
I mean, the proof is right here in the data. After just 24 hours, FlowFusion achieves way higher code coverage. That basically means it explores more of PHP's code. It pokes into more nooks and crannies than just running the official tests or even just crudely sticking them together. And more coverage means more chances to find bugs.
And oh, did it find bugs? During its evaluation run, FlowFusion discovered a whopping 158 previously unknown bugs in the PHP interpreter.
But a number's just a number, right? Here's what really matters. Of those bugs it found,
125 have already been confirmed and fixed by PHP's core development team. That means the web is genuinely a safer place today because of this.
And this isn't just about catching recent mistakes. Remember that bug from earlier? The one that had been lying dormant for over 20 years? Yeah? That's the kind of deep, ancient flaw that this unique approach can finally bring to light.
Let's break down another quick example. FlowFusion found this really critical error in the part of PHP that handles regular expressions. It happened because a module was shutting down before an object that needed it was finished. Now, the only reason it was found was because FlowFusion took a variable from a regex test and randomly connected it to a totally unrelated assignment from another test. It's a combination a human developer would probably never ever think to try.
So, what does this all mean for the future of the internet's security? Well, it's pretty big. Here's the ultimate proof that this thing works. The technique was so successful that the PHP project has officially adopted it. FlowFusion is now a permanent part of their toolkit, constantly hunting for new bugs before they can ever become a problem. It's like having a permanent, super smart bug detective on the team.
And all of this leaves us with one final, pretty important question to think about. We rely on so much of this foundational software every single day. So if the engine that powers over 70% of the entire web had these kinds of deep, hidden flaws, what other critical systems that we depend on might have similar bugs, just waiting to be found?